All right, my friends, let's get started. Before we get started, can somebody remind me what is the definition of slope? Rise over run. What does that mean in terms of a graph? How steep a line is, rate of change, I heard that as well, that is acceptable. When we are describing it mathematically, what does that mean? What does rise over run mean mathematically? How would I write it as an equation? y2 minus y1 over x2 minus x1. When you were in pre-cal, did you ever write it like this? No. Okay, so mathematicians are very lazy, and we have symbols for everything so that we don't have to write words. So this triangle means change in whatever it's next to. So this is saying change in y, or rise, change in the rise of something. That I don't have. Okay, so the triangle means we're changing something. In this case, we're changing the rise and we're changing the run. So this is what we're looking at. All right. Anybody remember the symbol for slope? M. We use M for the symbol for slope. So in lesson 1, what we're doing is we are creating a catalog of basic functions. Basic meaning what is the baseline information we need from each of the types of equations. We're going to start with linear. Power bar on my desk, if you can reach it, or there's one by the fridge, if you can reach it, whatever you can reach is fine. All right, so 3 different ways that we can write the equation of a line. The most common one that I'll bet you all remember is y-intercept form, which is y equals mx plus b. Do we all remember that? Okay, what does our m stand for? Slope. What does our b stand for? Y-intercepts. This is why it's called y-intercept form. There is point slope form. So if I told you there is a point on the graph with coordinates x1 and y1. Anybody remember how we do point slope form? You need a point and you need a slope. What do you think it is? Y minus y1 equals m bracket x minus x1. Okay, so here is my slope and here is my point. Point slope form. If you have any point and the slope, you can write the equation of this line. Okay, standard form. Standard form is where we have a x plus by equals c. Standard form we don't use too much just because it doesn't give us a whole ton of information. Point slope form we like a lot because it tells us the point and the slope, right? M always is slope. That's the symbol we use, so that's the symbol we're going to keep. And y-intercept form also gives us information, gives us slope and the y-intercept. Okay, before we move on, let's talk about domain. Anybody remember what is the definition for domain? Something about X. That is an example of a domain, but what's the definition of domain? Say that louder. Okay, so we're talking about restrictions. So domain is the allowable values for X. And range is the same thing, but allowable values for y. Okay, what is it allowed to be or what is it not allowed to be? Domain and range, we're talking about restrictions. Okay, so those are all our definitions. Let's take a look at our specific example here. We have the equation y equals 3x plus 2. What information do we have? Slope is 3. If I wanted to write it in rise over run form, how do I take a number and make it a fraction? 3 over 1. Right? So this is telling me up 3, right 1. What other piece of information do I have? Y-intercept. Right? This is my y-intercept. Remember that when we talk about intercepts, we're talking about a point on the graph. So how would I write this in as a coordinate? Is it 0, 2 or 2, 0? 0, 2 because it's a y-intercept, so the number goes with the y. All right, so let's graph it. My starting point is 0, 2. I'm going up 3 over 1, up 3 over 1. You could also go backwards as long as you're going the opposite direction. I could go down 3, left 1, down 3, left 1. And here is my line for this particular example. Okay. So now you have this graph next to you. I'm going to switch or move my screen over here. Looking at the graph we just made together, what would be the domain? What are the allowable values for x? Or you can think about, is there any value that x is not allowed to be? Can it be 0? Can it be positive? Can it be a fraction? Are there any restrictions? No. Okay, so we write x is or can be all real. Okay, quick aside here, you don't have to write this down. All real numbers in math, we shorten it to this fancy R, and it's not that fancy. You just do 2 lines and then an R. That's all real numbers. This symbol here means is a part of. So when I write this domain like this, what I'm saying is x is a part of all real numbers. This is why I like math. English takes too long. Right? We have our symbols to write our answers. Okay, range. Allowable values or restrictions. Any issues there? No. Okay, so y is the same. Y is also a part of all real numbers. No restrictions. Our y-intercept, you already told me, was 0, 2. Oops, that was a comma, not a point. How would I find my x-intercept? Make y 0. If I want to find an x-intercept, that means I'm looking for an x and I don't want the y, so I make the y disappear by making it 0. So I'm going to take 0 equals 3x plus 2, move the 2 over, divide by 3. Okay, so my x value is negative 2 over 3. So how would I write that as a coordinate? What's my x-intercept? The official way to write it. Negative 2 over 3 and 0. Yes. Okay, so whenever we talk about intercepts, we're talking about a coordinate. So we write them as a coordinate. Are we comfortable with this? We remember this from grade 10? 9 and 10? Okay, cool. So then in grade 11, you guys leveled up and started talking about quadratics. There are 3 different ways to write a quadratic formula, and each way tells us a different piece of information. So in standard form, we had ax squared plus bx plus c equals y. What information can I get from this type of equation? Yes? What else? is? Yes. This C value tells me the y-intercept form, or the coordinate for the y-intercept, which would be 0C, whatever the C number is. I'm also going to add here the third form, factored form. Let's separate this from question 1 here. Factored form is where we have y equals x minus a, x minus b, x minus, oh, sorry, quadratic, there's just 2 of them. What information can I get here? The x-intercepts, right? My x-intercepts are going to be a0 and b0. Right, so factored form tells us our x-intercepts. And last form, this is what we practiced last week, is vertex form, where we have y equals a, so some kind of number out front that we factored, x minus p squared plus q. Okay, what's important about this form? Tells us the vertex is at point PQ. So the reason we train you guys to be able to solve and rearrange equations is because if you understand how to rearrange them, you can get all the key points that you need from your different equations. In this case, we have a really basic equation. Here it is, y equals x squared. What do I know about this equation? I know the y-intercept is, so it's 0, 0. What about the x-intercept? Do we know the x-intercept? No? Can we graph it? Do we remember what x squared looks like? Where do I start? 0, 0. And then if x is 1, y is 1. If x is negative 1, y is negative 1. If x is 2, y is 4. Negative 2, still 4. And it kind of looks like this, right? A parabola. So what's my x-intercept? Also 0. Okay. Recall that x-intercepts is the same thing as zeros, which is the same thing as roots, which is the same thing as solutions. All of these mean the same thing. So when you say solve an equation, you're looking for x equals something. Find the zeros means y is 0. The roots or x-intercept. All these words mean the same thing. So now, keeping that in mind, let's take a look at our box of information. What is the domain? Do we have restrictions on x? No restrictions. So this is x is any number. Can be negative, positive, 0, fractions, doesn't matter. What about the range? Y is greater than 0. Has to be positive. Oops. Greater than or equal to 0, right? Because here, even if x is negative, it's still pointing up. Both sides of the parabola are pointing up. Our vertex, 0, 0, axis of symmetry, x equals 0. I'm going to cross this out because it's the same thing. All of these are 0, 0 because we have a basic function, x squared. We haven't moved it, we haven't shifted it, we haven't done anything to it. So far, so good? Moving on? Okay. Let's take a look at absolute value. Okay, when we look at an absolute value function, it is defined piecewise. So I'm going to write it this way. Piecewise definition means the result we get from an absolute value function depends on what we put inside of it. So the absolute value of x is going to be positive x if x is positive, greater than or equal to 0. But it's also going to be negative, I'm going to put x in brackets, if x is negative. And basically what this is saying is when you come outside of the straight brackets, your answer will always be positive. Okay, so if x equals 3, then the absolute value of x is 3. But if x equals negative 3, then the absolute value of x is negative 3. So it ends up being positive every single time. Whatever is inside the absolute value brackets will always come out positive. So essentially what that means is y is going to be positive in this case. When x is 0, y is 0. When x is 1, y is 1, 2, 2, 3, 3, 4, 4, and so on. But when x is negative 1, positive 1, positive 2, positive 3, positive 4. It has to always come out positive. So we end up with this V shape. Ooh, that was not nice. Let me try that again. V shape. Okay, you can think of it this way. Imagine if y equals x, we would have a straight line like this. Dotted line all the way down like this. Putting the absolute value function takes everything in the negative and makes it positive. So just flips it up. I could also do, let me try a different color here. If I had, let's say, a parabola that looks like this. If I put that parabola inside an absolute value function, it would transform into something that looks like this. The positive parts would stay positive. Oopsie. Let me try that again. Green parabola. The positive parts would stay positive and the negative parts would get flipped up. Okay, so absolute value function takes anything in the negative sides and puts them on the positive side. So looking at the blue function that we just graphed, what is the domain? Is x positive, negative, 0, fraction? Are any of those allowed or not allowed? Yes or no? They're all reals. We can put whatever we want into this function. Okay, what about our y's? Again, focus on the blue. Any restrictions on y's? Y has to be equal to or greater than 0, absolutely. And in this case, because we started at 0, 0, those are our intercepts as well. Okay, cubic functions. Did you guys go over some cubic functions last semester or whenever you took pre-calc 11? No? Okay. So cubic functions, very similar to quadratic functions. Different ways that you can set them up. I'm going to show you the two main ways that we're going to see it. In standard form. Standard form. we are going to have y equals ax cubed this time plus bx squared plus cx plus d. Because now we have a cubic instead of a quadratic. So we have one extra x, so one extra term. And just like with quadratic, this is going to be your y-intercept. Oopsie. Y-intercept in standard form. And then you're going to have factored form. X minus a, x minus b, x minus c. Any guesses what this information tells you? Your zeros or your x-intercepts. Okay, let's do some testing points. Since we've not worked with cubics before, let's do some tests. 0, +1, -1, +2, -2. If x is 0, y is 0. If x is 1, y is 1. If x is -1, y is no. -1. Okay, think of it this way. If I have -1 cubed, this is -1 times -1 times -1. Two negatives cancel. I have 3. Some of you who wrote the quiz on Friday forgot that tiny little detail. The exponent tells you how many negatives it is. So if that was squared, it would be positive, but it's cubed, so there's 3 of them, so it's negative. Okay, what is -2 cubed? -8, and positive is +8. So we're looking for kind of like an S shape. 0, 0, 1, 1, 1, 1. And then 2 is 1, 2, 3, 8. 1, 2, 3, 8. One thing you should know about cubics is that one leg will always be pointing down and one leg will always be pointing up. Sometimes they'll be in different directions, but always going in one up, one down. Okay, so looking at our picture, let's answer this. What is my domain? Do I have restrictions, yes or no? No, so this is reals. What is my range? Do I have restrictions? Say again? Not in this case, because I can go down, I'm going down and up. Always. So in this case, I do not have restrictions on y either. This is all reals. In my basic format, the one that we just drew, what's my x and y intercepts? 0, 0. Thank you. You're crossing the x and y axis at the same point right here. Okay. All right. Reciprocal. This is the one that I think most people struggle with the most, which is okay. With this one, it's easiest if you can imagine it with a table of values. So let's pick some values here. I'm going to do -10, -2, -1, 0, and then the positives of the same number. Can you take a moment with the person sitting next to you? Ooh, I'm sorry, I'm going to add one more. +1/2 and -1/2. I'll add that to the bottom there. Okay, take a second, sort this out.